evening. I'm Michael Tsai at the Data Room on Twitter. We have our friend who is founding a drone startup. Can you introduce yourself for our audience?
Absolutely. Glad to be here. Mike, my name is Farzad Rahbar. I'm the CEO and co-founder of FlyX Technologies. At FlyX, we've developed this wireless charging technology that enables drones to charge off of power lines, electromagnetic field, and therefore achieve unlimited flight range.
Very cool. Heard you might be joining the Stanford StartX program too.
Yes, we're looking forward to that.
Cool. FlyX at StartX. That's quite a mouthful. Cool. Well, congratulations. So what are we looking at here?
So this is our MVP where we have built the wireless charging technology that you can see underneath. Basically, it's a receiver that goes underneath the belly of the drones and enables them to basically use the surrounding energy around the power lines to charge the drone batteries and then continue flying. Our vision is to launch next generation of autonomous swarm drones that are able to perpetually fly and charge off of power lines, collect the data, and basically use that data to have a predictive maintenance, basically, and close a data intelligence gap between what we know and what's actually happening in the wild, so we can make precautious measurements before disaster like wildfire happens, basically.
So what sort of data are we collecting? Just to predict wildfires or?
Yeah, currently we're focused on that, so anything on the vegetation management side, or if it is anything to do with the structural integrity of the poles, wires, if there's a rust, if there's a broken insulator, anything to do with the health of the structure, basically. And those are the stuff, like if there's a branch of a tree getting close to the wire, it can cause spark, and that can cause wildfire. So we want to know those kind of issues beforehand so we can go cut those branches so it doesn't touch.
Nice. You know, wildfires in California have been getting worse in recent years, right? I mean, how much of that was caused by like power lines or whatever?
Well, most recently we had a problem in LA. So one of the transformers blew up. That was in Palisade.
Yeah, that was
the fire. Yeah, and also even worse than that was 2018 Camp Fire.
I remember that. That was
a
record.
Yes, exactly. So 85 people unfortunately lost their life. There was $15 billion in damages. And it's been frequently happening. The one happened in Maui or the one in Panhandle in Texas. So it's already the ones that we're seeing internationally in China or even in Turkey. So it's becoming frequent now because the asset is old. We're putting a lot of pressure on it due to electrification of the cars and data centers now. So it's like an old asset that you're trying to get a lot of energy out of, and it's failing, basically.
I see. So how much of the wildfire problem would you say is sort of like a predictive maintenance problem or like a data problem?
Seems like from whatever we see on the recent history of these large wildfires, it's all related to grid because of the failure of the assets. Because as we talked about, assets is old. It's mainly built 70 to 100 years ago, and it's so everything, there's tear and wear, global warming, and also the mechanical parts are like rust and things like that. They affect the integrity of these components that hold the wires basically together.
I see.
So
currently, are they just sending out manual crews to inspect and not catching things?
Exactly. So currently the methods are very manual. They're dangerous. People literally die while doing these inspections, whether helicopter that can crash into power lines or the some roads are not there's no accessible road to go there, so there's big intelligence gap between what the asset is. It's basically grid is the largest man-made machine, yet the tools
by surface area, right?
Yes, exactly. And the tools we have are very manual, costly, and dangerous, unscalable either. So what happens, it creates a data gap between what we know and what's actually happening in realities, and with asset getting old, so we need to do frequent inspection.
I see. Would you say this is the primary use case of your technology?
This is our first market entry, beachhead market for us. But obviously, the vision we have is to open up the existing power line infrastructure as a superhighways for drones. Basically, this infrastructure is leaking energy because some of it is wasted.
Leaking?
Yes,
Wow.
That's just physics of it. Like energy is like being wasted. So we are able to capture that and then turn it into DC power these drones that it can collect data and also later do maybe parcel delivery, physical AI type of work, maybe get them to do some maintenance or some sort of physical work in the wild, like in the middle of nowhere that's like humans cannot go or they can go, it's very costly to get there.
You know, Buckminster Fuller, he said, there's no such thing as pollution, just a waste byproduct that we haven't yet figured out how to convert.
Exactly.
So wow.
Exactly.
So
this is one of the applications
so
of that.
like basically power that would just be wasted or leaked anyways would go to this.
Exactly. Some of it comes from there, and 10 to 15% of it. The rest is coming from the field of the power lines. But we are also able to meter that energy, pay back to the companies
For however much you siphon.
Exactly. Exactly. And in another, also want to add that any wire anywhere basically becomes is a transmitter or energy source for us. Like later we can use railways, like the electrified railways.
Right. Can also be a drone railway.
Exactly. And we can inspect the railways with that.
I like that. You know, I've actually did study at the Mineta Transportation Institute about, we're big on trains. So that's interesting. I think that's a definite use case, I think.
Absolutely.
Could cut costs there. Huh. Okay, so your drone will just like fly and almost like perch on the power line like a bird and start sucking in energy.
Exactly, that's a great analogy. So these are like small, I mean, this is a slightly large drone just for the prototyping purposes, but later if you want to shrink the size down, we are a big proponent of making smaller drones. And then these drones will fly and we are able to fly them in a swarm fashion or formation and land on the power line like birds, charge, take off, continue flying, and then doing data collection or any sort of action. There's a lot of applications.
I see. Definitely, I can see a lot with some of the work I do. I could definitely see a use for extended range and in-field battery recharging. That could be very valuable for some of the stuff I do.
Absolutely.
Okay. Now, I'm wondering, could a big one be like a mothership that is like it recharges passively, but it has like a big bank, and like smaller drones can come in and like pull power off the big drone and then fly further out?
That's definitely possible, and it's a very interesting idea. It's definitely possible. The only thing is with the power lines, usually the asset owners, based on our research, they don't want to have a big drone like hovering around their assets or landing on their assets. So it's definitely possible if they allow us to do, but for currently we're just having the small ones that are directly charging.
True. Well, I don't know. I mean, I have a lot of friends in government. They have mixed opinions about working with PG&E, let's say.
Yes.
Some people really like them, some people really hate them. But it's mixed opinions. Okay.
Absolutely.
Well, I mean, supposedly there could be a future. I mean, I think some other countries would just be like, you know, the total utility of this is too great, where like if people don't want to cooperate, we're just going to tell them, hey, we're the government, we want you to cooperate.
Exactly. I mean, especially after showing the value of the technology and what we can do and avoid. And we can do scientific research. Like I know that like NASA launches aircrafts or drones to pick up on the pressure and like the temperature to predict where the tornadoes will go through in the land. So we can definitely launch these drones to go pick up those. So when we show, or if we can avoid the next wildfire, that's a huge value.
Yeah,
so
the property damage is immense.
Human loss, property. Now the insurance premiums have gone up. Some homes are not being insured anymore. And if we show that value and then get the help, leverage.
It's a very expensive problem.
Exactly. That will definitely help us. Like, will be a tailwind for us.
I think so, right? You know, they always say you want to target the biggest pain points, and I think that the California wildfires, I feel like people have grown numb to it. They're like, oh, it can't be stopped or whatever. But if you just measure the total economic damage and lost human lives, it's massive.
Absolutely.
So, through your recharging technology, what sort of range extension or battery life extension or payload increase are we looking at? over non-recharging?
Currently, so what we're doing, with drones, you want to fly longer, you have to carry a bigger battery. Bigger battery is heavier, so the drone becomes
Diminishing returns.
yeah, diminishing returns or counterintuitive process.
We see that in like the Starship rocket launches too, right? It's like, oh, you want a more powerful rocket for more payload. Well, you need more fuel for that. More fuel increases the weight, so now you need more power, right?
Exactly.
You rapidly approach this sort of like plateau
Exactly.
or of a hard limit.
Exactly.
Where
Exactly. So same goes with this with the technology we have, but the advantage we have is that we don't need to carry as big of a battery anymore. We can use our wireless charging technology. Usually, if this size flies for half an hour, charge around 15 minutes on average, and so you basically don't need to carry as big of a battery. You can just charge.
You're telling me I can fly for half an hour, charge for 15 minutes, and I'm back to full?
Yes.
Wow, so it's a 2-to-1 ratio.
Yes.
Of each minute of charge produces 2 minutes of flight time.
Exactly.
And what's the maximum amount of flight time with no charge?
Half an hour.
Oh, okay.
30 minutes.
So you can basically just time these like hops.
Yeah, and the fact that it's swarm, like if you want to get to a certain distance, you can instead of having one drone charging,
Say
you can multiple of them.
Some drones who are already in around that
Exactly.
area.
Some of them are flying, some of them are charging, so they kind of like
I see.
leapfrog, right?
Do you have some kind of software for fleet management?
We are working on that's in development process right now, so we can see where they are. And the great thing about this technology is because it's like autonomous, we don't have to have 1-to-1 ratio between pilot and the drone.
Yeah.
So you can have like 1 to too many. So one pilot may be overseeing 20, 50 of them doing their job and then taking over if there's any issues.
Yeah, that actually makes a lot of sense because right now one of our activities is we actually have an academy for training drone pilots because there is a real world supply crunch of skilled drone pilots.
Exactly.
So
because you can't copy humans, but you can copy robots, right?
Right.
Easily.
Yeah, I mean, how are they flying? Just like human joystick, or is it autonomous landing and?
Currently, we are, the level of autonomy is like from 0 to 5, like with autonomous.
Are you like level 2 autonomy?
Yeah, we are level 3 now. Right now,
Oh.
we are on the verge of going to 4.
Okay, great.
So if the regulations and the technology that we're developing catches up, then the goal is to make it 5.
I see. That'd be great. I mean, I can already imagine like the software layer in my head, just like Google Maps, like, all right, here's all the good recharging nodes, and it's like, if I want this drone to go there, how many hops do I need?
Exactly.
It's like, okay, like hop here, charge, hop, and the AI will automatically route it.
It will route it. It will say when to land, like how to land, stabilize.
Is the landing and like clamping to the power line autonomous, or does it have to be?
Yeah, all of those are autonomously
Wow.
done, and we don't clamp, we hug the wire, basically, because we're using the field around the wire, so it's not like actually drawing energy directly from the wire. Yeah, but that's exactly, all of them are done automatically, so it comes, lines up with the wire, it comes down, it sits there, turns off the motor, charges, turns on the motors and takes off and just carries on.
I see. About a month ago, there was a lot of talk in the news about this like trade war and the U.S. is being squeezed on rare earths. Do you see that affecting like the drone battery supply?
Currently, there's some of those like manufacturers are moving in. Currently, we are using like normal off-the-shelf parts, so we aren't really feeling that crunch. But if we kind of like start building maybe thousands of these, and if there's no manufacturing established yet in the U.S., then we will feel the crunch. But currently, so far so good.
Okay, that's good. But I don't know. I feel like it's good to have some extra capacity in case we eventually get squeezed on.
Absolutely.
On batteries.
Absolutely.
How many recharge cycles can a battery take from this technology?
I believe it depends on the good quality ones are around like ranges between 5,000 to 10,000 cycles.
This is agnostic to the battery?
Yes.
Oh, wow.
Yeah, it can charge any battery, and we can make it because we have the IP. We've developed that IP of like different sizes and different drone requirements for power. We can change the size or make it fit that requirement, basically.
Are there any drone models or batteries that you currently think would fit well with this recharging technology?
Yeah, small battery sizes like the drone size around like 4 pound or less, and the drone size battery size around 4 to 6 cell. is the sweet spot for this design that we have for the MVP. But as you said, we can make it bigger to output more power, or make it smaller to output less power and then be more lighter. So it depends on that customer need if they want us to give them a custom solution.
Okay. Just out of the blue, would this be able to attach to even like an old drone from 2016 or?
It will be. Depends on the drone itself. Like drones like DJIs of the world, they're like closed systems. So we have to be able to talk to the flight computer to be able to put those like AI algorithms in it so that it can go land and do all the stuff that we're doing. But if it is like open system that we're using right now, like Linux-based systems, then it's obviously we can easily integrate with those.
I'm a little biased, but I am a big fan of open systems, and
Yes, yes.
I have some other friends in the space, like Flyby and K9 Robotics, where they're all about these more open drone systems.
Exactly, and that's what we're deploying. We're
Right.
using open system because
Right.
otherwise,
Right, and even when we're talking about just like maintaining the U.S. infrastructure grid, right? There's been some national security concerns about like,
Exactly.
okay, what about those foreign-made drones, right? Oh, so everything here is made in America.
yes,
Wow.
all of them are made
That's
in
very good.
America. Exactly, all the data, all the engineering, all the software, all the cloud data or whatever, they're all in America.
That's
and
great.
we are a Silicon Valley-based company.
Exactly. I mean, if we're going to be having this technology monitoring the nation's critical infrastructure, right? We're American-made all across the stack. That's great to hear.
Exactly.
It's really great to hear.
Yeah, exactly. Yeah,
Cool.
definitely.
Can I ask how much your recharging unit weighs, or is that?
It's around 1 pound right now,
Oh.
but we're pushing it to be half a pound.
Okay, but even at that weight, I mean, how big or powerful a drone do you need to carry that? That's a
Usually it's like very small, like a low class of drone, like light class of drone, like around 4 to 5 pounds.
Okay.
It should be easily able to carry that. But one of the analogy we have, say you have a drone that has a 2-pound battery. As a drone OEM, we come to you say, hey, okay, you can pull that battery off and then give half of that, like make it half size capacity and give the next half weight for us to replace our wireless charging. So it's same weight. So we're not going to add anything on the current drones. We just replace the battery size, shrink it to half, because you don't have to carry as big of a battery
in
anymore.
the field, we've already seen our operators with attach huge battery packs to the drone, take it off, put in a fresh battery.
Exactly, exactly.
On the large end, I mean, have you seen like the DJI Matrice and like
Yes.
these giant agriculture drones?
Yes,
Like what about combining it with some of the biggest drones?
that's definitely possible, but the only thing is, as I said, we have the IP, we can make it work for those as well. It's just, as long as like on transmission lines, you have like a 50-pound sag limit between poles. So
that's your real hard limit.
yeah, exactly. So, and if there's only one wire and you are on a transmission line, then you're fine. We can go land on the transmission line and do that.
Yeah, just imagine the whole thing with a bunch of pigeons on the power line, but now you have a bunch of drones
Yeah.
perched on the line.
The only thing is, the large drones, they're not any more pigeons. They're like eagles.
Eagles, yeah.
Eagles sitting on a wire. But if it is,
Hey, I had an idea though. Since you say 1 minute of charge produces 2 minutes of flight time,
yes,
what if the drone was hovering while charging?
that's possible too.
So it's not doing a sag weight on it.
Yeah. If you look at our patent, we have that as well. It's just it has like more difficult problem solved because you have to be able to control that distance within a certain distance. You have to say, and also efficiency wise is not a good approach. The reason being you're consuming power
As you charge.
while hovering. But the thing is, because we're producing a lot of power and efficiency, our delta, which is inflow, is more than the outflow, even
Right.
in hour. So you can be positive. You're positive, you're still charging, but it's going to take longer.
Right.
So that 1 to 2 minute ratio may not be
Right.
there.
So my sense is if you're hovering while charging, you're charging at half speed, because each minute of charge produces 2 minutes of flight, but
Yes.
using 1 minute to hover. But
Exactly.
you get a delta of 1 minute charge.
Exactly.
Okay.
It's just longer. Exactly.
Well, I think it's cool, right? Like I used to study aviation a lot. You've seen the mid-air refueling with the KC-130s, right?
Exactly.
Right. You're burning fuel while you're gaining fuel,
Exactly.
but that's quite a delicate maneuver. I mean, mid-air refueling is one of the hardest, trickiest maneuvers to pull off. So
This is similar. Very similar.
Instead of before it was mid-air refueling. Now it's mid hover recharging.
Exactly. From infinite pool, like
Okay.
that KC 130 is just going to run out of gas if you
Eventually,
use it. Yeah,
right.
eventually. But this is just like infinite, abundant amount of energy.
So you said you used to work in aerospace.
I am an aerospace engineer. I used to be a jet engine design Rolls-Royce. I've been building planes for large aerospace companies.
Wonderful.
Yes.
I grew up loving planes. It's
Me
it's a
too.
funny story. Like when I was really young, I just thought a lot about aviation, and I had an idea, and I thought my idea was so brilliant. But basically, when I was like around like 8 years old, I had independently discovered the Kawanda effect.
Okay.
I was like, okay, if this is how a wing works, what if we suck in from the top and pump out from the bottom, right? So I thought I was a genius. Like, I have this great idea, right? And I did more research. So like, GE invented this in the 1970s. I was like, damn, I was born too late. Everyone invented all the good ideas already, so I can't, even though I independently discovered it.
That's good.
So someone's
Good.
go like, yeah, I was just born 40 years ahead of you, and I discovered it.
I figured it out.
I was like, but there's always something new to discover.
Yeah, of course. There's a lot of now move to supersonic and hypersonic.
Oh yeah,
versions.
yeah. We've seen definitely more tests. Well, these definitely are not supersonic, but I think a lot of that,
subsonic.
a lot of the action still happens at normal speeds, right? It's at the end of the day, it's all about efficiency.
Exactly.
Cool.
Exactly.
So, what do you see as the future of this space over the next few years?
I think that we will be able to launch next generation like small drones that are able to work together in a swarm fashion and also do work, like maybe carry heavy loads, let's say, and like if you have 100-pound payload, you can have hundreds of drones that can carry each 1 pound and then launch them in a team that they can talk to each other and can carry stuff together, or even using them hopefully to avoid wildfire, but also even if after that happens, maybe using
The fire
it-
suppression.
Exactly.
Like one of the things we've actually been researching is firefighting grenades. So, like, right now we see the wildfires. They're taking like helicopters and tanker planes and dumping water and fire
Yes,
retardant. But it's
exactly.
it's expensive and risky.
Risky
And it's slow.
and probably inefficient as
Yeah,
well.
yeah, because you gotta like fly and scoop up the water and
Yeah.
go out. And in the time it takes to do all that, the fire's spreading.
Yeah, exactly.
Whereas if you can detect like the down power line or spark immediately and like put it out while the fire's still pretty
Exactly.
small. I mean, the whole saying an ounce of prevention is worth a pound of cure is very true in firefighting.
Absolutely.
We studied emergency management. Yeah, I'm just thinking we take one of these and the payload is like a small capsule with like, fire extinguishing material in it.
Yeah,
You just
yeah.
fly over the fire, drop it, it bursts into air and throws
Exactly.
like chemical retardant over the fire.
Exactly. Or another thing is I'm all about prevention. Like if we, as you said, if we can stop it from happening, then it's even better. There's actually a company in California which I was talking to. They've invented this material. Like it's a liquid that you can put wherever that you don't want to have fire. Like fire literally.
Like a fire break.
Yeah, fire. It burns, and when it reaches this line, it can't cross. So what if we spray all this material
Also,
on
like
the
there's a fire here, so send out drones, then put a
yeah,
down a
even
line.
before, like if there's a fire-prone areas, what if we spray them ahead of time, like around the houses or around the
Well,
assets?
how
like
long does it last?
1 year.
Wow.
It washes out after rain, like 1 year, like
Okay.
over 1 year.
Is it toxic?
No, actually, the great thing about this company is that their material is not toxic, so they can use it in the environment, and they've passed California like certifications.
That's great. So 1 year, because I know in previous years with the wildfires, right? Some of my like celebrity friends, they have mansions in the hills,
Yeah.
and they actually had a private crew come up and like spray like a fire retardant fire break to like in case like an ember lands on their house, right? And it's not
Yeah.
preventive, but that's like last minute. It's like if you know the fire's approaching in like 24 hours, you get a crew to spray this chemical on your house and spray around it. But this
Exactly.
is 1 year out.
Yeah, 1 year out.
Huh.
Actually, there's a lot of households that are using this material to guard their property. But I've come up with the idea, because we don't have a range problem. What if we send hundreds of these to go, just put it around the areas that you want to protect, like in the larger area, and power line is everywhere, right? I
can see like a whole like gated community package for this, right? Because honestly, we were already looking at using drones for like private security. I mean, if you look at some of these gated communities around Silicon Valley,
Absolutely.
they're already saying, local police patrols are not enough. We want to pay for additional private security on top of
Exactly.
that. But I mean, security, it comes against not only like malicious actors but fires too, right? There's
Absolutely.
I mean, something doesn't have to be malicious to be dangerous. Fire has no ill intentions. It's just dangerous.
It's just inherently dangerous.
Right.
Exactly.
It doesn't hate you. It's just
Yeah, it's just the nature of it.
Right.
It has to burn everything. Yeah, absolutely. That's why I was mentioning about physical AI. That's what I'm very excited about. Getting them to do work. I mean, the data is a kind of work as well, but like, what about getting them to do physical work?
Okay. So how would these recharging drones do physical work?
Like, you can literally put an like robotic arm on them, and then maybe
It can support that weight?
Yeah, of course. Like a smaller size, like
Okay.
lightweight, and then maybe have like a cutter or something to cut branches, or like, as you said, like put some sort of like tank, and then have them to spray that material over wherever. Or bring water from lake to help to suppress the the fire.
It's a lot of trips though. Water's heavy.
Yeah, but if you don't have like scalability problem, then you can
A lot of like 1,000 of these
thousands of them. Yeah, it's like mosquitoes, right? Like
Right,
just launch
like
them.
tiny.
Yeah,
each
bam,
one
bam,
carries
bam. They're just going through like a
Yeah.
route and then doing the work,
Makes
and then refuel while like.
Yeah, it could even just pass like spray it, keep the area moist, so it doesn't
Exactly.
turn to dry brush.
Exactly. Or like if sometimes we have thermal camera on this drone where
Oh.
it sees hot spots, like that's how it just detect the potential wildfires. So what if it goes and brings water and just dumps some water on that like hot
That would be
spot?
good,
It
right?
just-
You can have like a nightly rotation, like a thermal drone on patrol. So the moment you have a down power line, it spots it almost immediately,
Exactly.
and there's already another drone on standby with water.
Exactly.
Yeah, I would just put some of these drones near like where the infrastructure is weak. So like these are likely spots where a fire might start,
exactly.
and just have like
Just sit there even like
right,
wait.
just wait for something bad to happen and then solve
take
it
off
immediately.
and then or human launches. They may go look at for something like specific. For
Yeah,
them.
rapid response time I think can save so much.
Yeah, exactly. Because these drones are built to live outside. They're not coming. They're not DJs of the
Oh,
world. They
speaking
come-
of living outside, how rugged are these? Can they get rained on? Like, what if there's a
This is an
windstorm?
MVP, so it's gonna leak right now. But the goal is to make them ruggedized. They're gonna be living outside. So if it's like cold temperature, they have like
Okay.
heaters to just.
You want to put like a little like storage, like a home for the drones. Like, oh, time to go home and sleep for the night.
No, I was just leaving them on the wire. Just sit them, just turn off, and then let
Like
them.
the birds like fall asleep. perched
Yeah,
on the wire.
exactly.
Okay,
Yeah, just wait there until I tell you
I see.
to take
So
off.
do you have to like park it right in the middle for the sound?
Doesn't
'Cause How
matter,
does it
no.
stay balanced on it?
Is if while charging turns off, but if the AI, the edge computer we have on it, like if it goes unbalanced, it turns off one of the propellers.
So is it
Just
like a
off.
Segway auto?
Yeah, it's like
Wow.
those guys in circus, like
Yeah.
they have some sort of like balancing. thing.
Can I see the auto balancing in action sometime?
Yeah, exactly. We're getting ready to do demos in the field, and those will be visible in that.
Wow, I look forward to seeing it.
Absolutely.
Awesome. Do you have any more thoughts for us?
No, we're very excited about what we're doing, and in a couple of years, these will be in the action. We hope that we can avoid the next wildfire, add a lot of value, unlock the potential of existing grid infrastructure, do a lot of things that we want to achieve, and help the society, basically.
I see. Do we need to build a lot more power lines in the U.S.?
Absolutely. I think they are estimating that the grid has to double or triple by 2050 because of the AI and
Yeah,
electrification.
the AI
and all
boom
that.
is causing so much
So,
electricity demand.
Exactly. So
Our
not that we all have to take care of the old grid. That's sort of it all has to be expanded and doubled or even tripled in the U.S.
Right, but I think this gives a strong use case because when you build more
Absolutely.
power lines, you're not just building more power lines, you're building drone highways too.
Exactly.
Yeah, no, I
And-
mean, in my study of like urban leadership and management, right, we're even looking at how do we put AI into traffic lights and the lamp posts, right? How do we turn those into like smart nodes?
Yeah,
So
exactly.
I like how this uses existing infrastructure, but as always, we should try to build towards the future.
Absolutely. I mean, future of smart cities, digital transformation, getting that knowledge and basically closing that data gap, is what we're driving this thing to.
Okay. And the last question, and the physical AI element of it, I've been hearing a lot about it so much. How do you see this affecting physical AI or being part of the physical AI transformation?
I think we can get it to do some of the like more mundane, like hostile type of work, maybe like maintenance on the lines, or as we said, like talking like cutting like light vegetation, or um, uh, anything that even like sometimes they use robot dogs, like having a coordination between drones and like the ground vehicles, if you like, because like having drones flying and then sharing that aerial data with the one which is on the ground, maybe passing on the information or getting that, like getting robots to work together basically.
Got it.
And doing work, right? From security of large properties or like even neighborhoods to farming to like seeding and spraying, like those kind of stuff is definitely the future, you know.
Awesome.
Yeah.
So, well, looks like we have many possibilities ahead.
Absolutely.
Thank you for your time.
Thank you very much. Thanks, Mike.